Hi everyone, welcome back. We are in Module 2. We are in Topic 2. We are on Lesson 3 and we are on the introduction. The forest for the trees, determining the part and the whole in percent problems. Learning goals. Use ratio and rate reasoning to solve percent problems. Solve percent problems for the part given the whole and the percent. Use ratio reasoning to estimate the value of the whole in percent problems. And solve percent problems for the whole given the part and the percent. So quick review, determine the unknown quantity in each portion. So we are wondering how is 6/8 equivalent to something over 12. So how do you go from 8 to 12? That would be 8 times 1.5. So then in the numerator we're doing the same thing, 6 times 1.5. So 6 times 1 gives us 6, and then half of 6 is 3. Add those together. Just going to zoom in and I'll just slide it around here. So that equals 9. So 9/12 is the equivalent of 6/8. Okay. So then the next one, something over 16 equals 15 over 40. So this time we're going in this direction. So how do you go from 40 to 16? That is a divide by 2.5, divide by 2.5. And if you didn't know, you could do 40 divided by 16 in a calculator, and you should get 2.5. 40 divided by 16, 2.5. There we go. Reflection of the light. Okay. So then 15 divided by 2.5. So that light is really on that today. 15 divided by 2.5. So we get 6. So that question mark equals 6. So 6/16 is our final answer there. And then lastly, 6/15 is equal to what over tenths? So 15 to 10, that's a divide by 1.5. So 6 divided by 1.5 gives us 4. So 4/10 is the answer there. Okay, that was on page 281. Guess I didn't tell you that part. Okay, we are not doing the getting started, so we're going to skip that. We're going to move right on to activity 1. So in activity 1, you're going to have to take a minute. You're going to need to pause and read each of these, please. So calculating percent of a quantity. Where habits of mind got a model with mathematics and use appropriate tools strategically. Mr. Goodwin, the 6th grade math teacher, asked the class to determine 25% of 44. 5 different students responded with their strategy. Pause at this point and read each of them. Okay, trusting that you did that. Okay, so Kendra says, since 25% of 44 means multiplying 25 over 100, 25 hundredths times the quantity, I use the fraction method. So she said 25 over 100 equals 1/4. Then I multiplied 1/4 times 44 because it's 25% of. So she's saying that the 1/4 is equal to the 25% of is times 1/4 of 44 is 11. Hank says, I like decimals much better than fractions. So for his 25 hundredths, he put it as 0.25, and then he multiplied that by 44, still got 11. Ryan says 25% is easy to do in my head. 50% of 44 is 22, and 25% is half of 50. So 25% of 44 is whatever half of the 22 is, which is equal to 11. Simon says, since 25% is the same as 1/4, I just divided by 4. 44 divided by 4 is 11. And finally, Pamela said, I prefer to use the benchmarks of 10 and 5%. 10% of 44 is 4.4. So then she takes it a step further here and says 20%, because remember we're aiming for 25%. 20% is 2 of the 10%. So 2 of the 10% value, which is 4.4. So that really says 2 times 4.4. I'm not a big fan with how they have that written because their decimal point and the multiplication sign are such teeny tiny little itty bitty dots, it's kind of hard to tell what they're actually meaning. So 2 of the 4.4, so you get 8 and 8/10. And then half of the 10% gives you the 5%. 5% is half 10%, which is going to be 2.2. So then as she's adding those together, she's adding together the 8.8 and the 2.2 to get a total of 11. So they all get the same thing. Go about it a different way for each of them. Then page 285 says, when is Kendra's method most effective? Take note, a more efficient method is one that requires fewer steps or simpler steps to determine an answer. So when is Kendra's method most efficient to use? So let's peek back here at Kendra. So she did 1/4. So she took a fraction and multiplied it by the whole number. So how do we say when is hers most efficient? So we can say for hers, when you can easily convert the percents to fractions. When is Hank's method most efficient? So Hank says, I like decimals much better than fractions. So Hank's you can really use anytime. And this method, using multiplying by a decimal, like you can multiply by a decimal at any time. It works well. With more complicated numbers. When is Ryan's method most efficient? So Ryan said 25% is easy to do in my head, 50% of 44 is 22, 25% is half of 50, so 25% of 44 is 1/2 of 22. Which is equal to 11. So I think his was easy because he had these fractions which were easy to convert. So when the percents can convert easily, let's say when the percents can convert to fractions like 1/2 and 1/4. That's a 1. Easily. Maybe I should zoom out here a little bit. Okay. Sorry about that. When is Simon's method most efficient? So Simon said since 25% is the same as 1/4, I just divided by 4. So you can only, so he took that denominator and divided by 4. So the only time you can do that is when your numerator is a 1. Because remember, what he really did is 1/4 of 25, multiplying straight across, he got 25 over 4. So there's where he got the divide by 4. So his is most easy to use, most efficient, when you can write the percent as a unit fraction. Remember, that means there is a 1 in the numerator. That's our definition of unit fraction. When is Pamela's method? So Pamela used the benchmarks. So obviously the percent that we're working with has to be pretty easily attainable with the benchmarks. So that's how we're going to answer that. And the percent can be easily reached using benchmarks. Okay, and we're going to move on. We'll let that there for a second so you can finish copying it. I'm going to move on to page 286. 286, finishing activity 1. Ellen said, all the methods are correct and everyone got the correct answer, but what if Mr. Goodwin gave us the problem 32% of 732? So let's take a look at everybody's use then. Kendra says, my fraction method is not as easy this time. So 32% is 32 over 100 times 732. That's not quite as easy. Hank says, my method is not any more difficult. 32% is 0.32, so 0.32 times 732. So his was still easy. Ryan says, I can still estimate, but my answer will be close, not exact. So he's saying 32% is close to 1/3, and 1/3 of 732 is 244. So it's hard to get a fraction out of 32% as he did in the other one. Simon says, I don't have an easy fraction to use for 32%, so my method works only for certain percents. Pamela says, I can still use my method. 32% is made up of 10% plus 10% plus 10% plus 1% plus 1%. She says 10% of 732 is 73 2/10. 1% of 732 is 7 32/100. She has 3 of the 10% multiplied it, got that. 2 of the 1% multiply, got this, and then added them together. You could add 73.2 plus 73.2 plus 73.2 plus 7.32 plus 7.32. You could have done that as well. Okay, which method do you prefer with this particular percent of a quantity? And then explain your thinking. So that's really going to be kind of your preference here. How would you answer it? Like maybe you're going to say Hank because his works all the time. Okay. That's going to be your choice. You answer this. You answer. All right, number 3, determine the percent of each quantity. So we're going to use Hank's method to do this. We're going to use Hank's method. I'm going to zoom in a little bit here. So 7% of 80. So how do I write 7% as a decimal? 0.07 of 80. I wonder if I can, nope, see, and then you can't see. Oh, there we go. Okay, 7% is 0.07 of times 80 is 5 6/10. If we wrote it out like this, 7 times, like this, 7 times 0 is 0. 7 times 8 is 56. 2 numbers behind the decimal. I don't need to do this whole next row because it's 0 times everything. So 5.6. Letter B, 15% of 55. So 0.15 times 55. And you can probably use benchmark percents to figure that out pretty quickly. Right? 10% is 5.5. And we would do half of that. And we're going to add that together then. But I want to do Hank's method. I want you to have some familiarity with that as well. So 15% is 0.15 times, what was it, times 55, 8.25. %8 of 300, 8% is 0.08 times 300. So if I kind of up here say 300 times 0.08 is 8 times 0, 0, 8 times 0, 0, 8 times 3, 24. I don't need to do this next row because it's just all zeros. I have 2 numbers after the decimal point. So I should get 24. We'll verify that on the calculator. 10% of 300 would be 30, so it should be correct. So 8% of 300 is 24. Okay, letter D, 12.5% of 64. Okay, so now our percent has a decimal in it. So remember, when we're writing a percent as a decimal, we're moving that decimal point over 2 places. So 0.125 is how we're writing 112 and 5/10 of a percent as a decimal, right? Because here it was 7, it ended up being 0.07. Here we had 15, moved it over to 0.15. 8, moved it over to 0.08. Okay, so 0.125 times 64. .125 times 64 is 8. It makes sense. 10% of 64 would be 6.4. So we expect it to be a little bit more than the 6.4 because we're at 12.5%. 37% of 120, 0.37 times 120. 44.4. And then lastly, 150% of 27. So that's going to be 1.5 as a decimal, moving the decimal point over 2 places. Of 27, 1.5 times 27 equals 40.5. Does that make sense? 150% of 27, we're doing more than 27. 100% of 27 would be 27. I just want to kind of show you this with benchmark percents. 100% of 27 is 27. What's 50% of 27? What's half of 27? Well, half of 20 is 10. Half of 7 is 3.5. So 13.5. And if I add those together, 0.5, 0, and 4. So you can use benchmark percents even when it goes above 100. Okay, I think that's all we have for activity 1. It is indeed. We'll see you for activity 2 on the next video.